All right, guys. Shh. You guys listen, please. Good afternoon, guys. I'm so... Good afternoon. Yesterday, I started talking about sampling distributions. And if you guys were in the lecture yesterday, I wanted to talk about three sampling distributions. And yesterday I did talk about one of the first of the three distributions, which was the chi-square distribution, guys. Now today, so I talked about this yesterday. Today I'm going to talk about. Hi. Okay. All right.
Sorry.
It's all right. Take your time.
Just a big lecture. We don't want to miss it.
You guys made the same announcement yesterday. It's the same class.
Same class?
Yeah, same
okay,
class.
Sorry then. We said, okay.
No, it's the same class
Same
as
class.
yesterday.
I said, sure, have you guys voted?
I'm sure. No, it's the same class as yesterday. You
Okay,
did.
then we just ask them, have you voted, and we'll leave.
All right, okay. Do you only use the microphone? It's this one.
Yeah, sure.
Hi guys, it's us from yesterday. Hey, quick question, have any of you guys voted?
From yesterday we spoke so much. Has anyone voted yet?
Nope.
Okay.
Gonna remind you to vote because voting closes at Thursday at 5, so it's really important that you vote. Vote ENAS number 1 for community and Redeem number 1 for diversity. Yeah?
Yes.
Thanks guys.
Thank you. Thank you.
All right, bye. All right. Yeah. All right. I'm running for president, and maybe you guys can vote for me. Right. Anyway, I talked about the chi-square distribution yesterday. Today I'm going to talk about the second of the three sampling distributions, which is the all right, so guys take a seat, please. Right, okay. Today I'm going to talk about the second of the three sampling distributions known as the student's T distribution. The notation is as follows. We write that a variable x has the T distribution with parameter A if the PDF of x is as follows. Sorry, A. This is A, guys, sorry. A, okay. So this is the probability density function of the student's T distribution, and it's defined over the real line, the whole real line, and the parameter A is strictly positive and is referred to as the degree of freedom. the student t distribution is due to an English statistician. His name is William Gossett. This is the guy, William Gossett. He's an English statistician. The student t distribution is due to him. The reason that the name student came about, because this guy, he worked for the Irish beer company, Guinness. I'm sure you know Guinness, right? You know the beer company, the Irish beer company, Guinness, and one of the policies of the company was that you're not allowed to sell your research in the public domain. So he wrote all his papers under the name student, without his original name. His real name is William Gossett. So that's why the name student came about, right? All right, guys. Now, let me put it here. Now, if you, I'm not very good in drawing, guys. If you plot f of x, this is f of x, guys, here. If you plot f of x versus x, it will look something like this. And what does this remind you of, guys? It reminds you of what? The PDF of the normal distribution, all right? The only difference, all right, let me, this actually, right? The main difference, I know I'm not good in drawing, guys, but the main difference between the PDF of the normal distribution and the PDF of the student's t distribution is that the normal distribution decays to zero. Decays to zero. In other words, it decays to zero on this side, and on this side much faster. So these two tails here, these two tails are exponentially decaying they decay to zero exponentially as you go to plus infinity or negative infinity. So this is negative infinity, this is positive infinity, right? Whereas the tails of the student's t distribution, this one and this one, they decay to zero polynomially, polynomially decaying tails. So obviously the tails of the student's t, they decay to zero polynomially. The tails of the normal distribution decay to zero exponentially. So exponentially is obviously much faster than a polynomial power, all right? That's why they look like this. And there has been a lot of research, even as recent as 2015, 14, etc., comparing the PDF of the normal distribution to the PDF of the student's t distribution. In particular, looking at the points looking at these 2 points where they intersect each other. These are the 2 points where the student's T and the normal PDF intersect each other. And there has been some amount of published research in mainstream journals about this, the intersection points between the 2 PDFs. So I'm telling you this because I want you to become interested in statistics, even if you don't like this course. All right? Okay. All right. Okay, now there are some properties. Some of the properties of the student's T distribution as follows. A, if Z and U are independent, Z is a standard normal, U is a chi-squared variable with a degree of freedom, then this guy here has a T distribution with parameter A, right? That's property A. Property B, if you have a random sample from a normal distribution with these parameters, then this guy here has a T distribution with n-1 degree of freedom, right? where x bar is the sample mean, and S is the sample standard deviation, which is defined by, I'm sure you guys know this. All right, so this is the sample mean, and this is the sample standard deviation, right? So that's 2 properties. The next one, property C, is that the expectation of a T variable with parameter A is equal to 0. Property D is the variance of a T variable is equal to A divided by A minus 1. And property E is that it's a T random variable with parameter A approaches a normal variable, approaches the standard normal variable as A approaches infinity. So these are 5 properties of the student T distribution. Of these, I think I mentioned this to you guys yesterday. Of these 5 properties, you should be able to prove property B, property C, and property D, right? I will so you should be able to prove B, C, and D. I will in a minute I will show you how to prove some of these properties, but not all of them, because as you know, I only have a certain amount of time to see you guys. So I mean, if you have difficulty proving the ones I haven't proved, just please send me an email or come and see me in person, right? I'm available anytime. I mean, somebody asked me yesterday, but I'm available from 11 to 5 every day except Monday. Mondays I'm not in Manchester. So Tuesdays to Friday I am available from 11 to 5. So you can come, drop in and see me anytime. You don't need to make an appointment, right? All right, so these are the three properties you need to be able to prove. Now, I will show you in a minute how you prove some of them. All right, the next one, so this is the T distribution, which is the second. Remember what I told you guys yesterday. I was going to talk about 3 sampling distributions. So far, we talked about 2. The third one, is the F. The third sampling distribution is the F distribution. We say a variable x has the F distribution with parameters a and b if the PDF of x is as follows. So all right, this is the probability density function of the F distribution, and it's defined on the positive real line x greater than 0. And the 2 parameters a and b are strictly positive, right? A is known as the first this is known as the first degree of freedom, and B is known as the second degree of freedom, right? Okay, guys. Typically, if you plot f of x versus x, it will either look like this or look like this. So these are 2 possible shapes of the density function of the F distribution, right? All right, guys. Some properties of the F distribution. Once again, I will tell you which ones you need to be able to prove. The first one, A, if you have 2 chi-squared variables, chi-squared with parameter A, chi-squared with parameter B, then then this guy here must have the F distribution with parameters A and B, right? That's property B. it will take me a while to write this. Just a minute, guys. So you have two independent random sample. The first sample is from a normal distribution with these parameters. The second sample is from this normal distribution with these parameters. Then the result says the same thing. The result says that the following, that is the ratio of the sample variances as an F distribution with these parameters, right? Where S1 squared is the sample variance for the first sample. In other words, right? And S2 squared is the sample variance for the second sample. Right? And x bar 1 is the sample mean for the first sample. In other words, is this one. And x bar 2 is the sample mean for the second sample. Okay, so this is the result, guys. Okay, so those are two properties. The next one, so let me put this over here, guys. Hopefully you can see this. Property C is the following, that is, if x is a f variable with these parameters, then 1 divided by x is also an f variable, but with the degrees of freedom switched around from a to b to b to a, right? D, the expected value of x is b divided by b minus 2, where b must be greater than 2. This is D, okay? And property E is that the variance of an f variable is, sorry guys, this should be, my apologies, this should be 2, okay? Not b minus 2, guys, sorry. B divided by b minus 2, okay? The variance is 2 b squared yeah, this is the formula for the variance of a f variable with parameters a and b. And finally, the final property is that if x squared will have an f variable with these parameters. All right. So these are the properties of the F distribution, and of this property you should be able to prove all but the first one. So you should be able to prove all the properties except property A. Now, in the time remaining, I'm going to show you how to prove some of the properties. We've got about 30 minutes left now. Okay, guys. So let's go back to what we did, the chi-square distribution we talked about yesterday, right? I only have like half an hour to prove some properties, but I will try my best to prove as many as possible, guys. So some proofs. The first one, right? All right, I want to prove this is one of the properties I mentioned to you guys yesterday, in the lecture yesterday, guys. All right. So I want to find the MGF of a chi-squared variable, right? So it will be yeah. Remember, the MGF is simply this multiplied by the PDF of the chi-squared. This is the PDF of chi-squared, right? Now I'm going to make a substitution that y is equal to x by 2. So that implies that x is equal to 2y, and this implies that dx is equal to 2 dy. So if you make this substitution, sorry guys, sorry. I'm sorry. I think this is the wrong substitution to make. Look how stupid I am. All right. Anyway, sorry guys. This is not the right. You should have known then. You should have known. This is not the right substitution to make. It will be. Come on, guys. You should have known better. All right. Now this integral is equal to this, yeah. Okay. And now I'm gonna make a substitute. I'm gonna make the following substitution, that x is equal to half minus t. Right. So that means, sorry, y is equal to x times this. All right. So that means x is equal to and dx is equal to dy Yeah. So I'm making this following this substitution. Right, under this, if you sub this into this, guys, you will get this minus y, and dx will become this. All right. All right. Now this All right, now let me ask you guys, what do you know about this integral here, guys? This integral here is equal to? Huh? This is the gamma function at a by 2, right? So this guy here cancels out with this guy, and the answer that you will get is 1 minus 2t power minus a over 2. And this is what we wanted to prove. It's not hard, is it, guys? Yeah? Or is it hard? It's just simple substitution.
Can I ask where the A2 exponential, the exponent comes from? For the right at the top,
Yeah?
it seems to have one, whereas you've got 2 gamma of A2 right at the top.
Over here, sir? Or no? There's no gamma here. Well, you mean here, this one here?
No, I mean at the top. So right after you put the moment generating function, right after you start the proof,
Yeah.
you've got e to the tx, 1 over 2 gamma of a over 2.
Yeah.
And
Yeah.
then when you bring that outside the integral, there's then an a over 2.
Oh yeah. That's because there's a 2 here,
Yeah.
and there's a 2 here. If you combine the 2, you get this. You see that now? You should combine this 2 and this 2, because this 2 is raised to this power.
Yeah.
All right. So if you combine these 2, you get this.
Got it. Yeah.
You got it? Yeah, good. All right. So any other questions, guys? This is easy proof, right? So maybe. Oh man. Okay, that's one. All right, guys. The next one I would like you. I would want you to prove. I would like to help you with, guys, is the following. You guys listen, please. Proof. The next one, I'm trying to help you guys, right? Because there are so many properties I've given you, and I can't prove all of them. I mean, I'm trying to help you guys to prove some of them so that you can prove the remaining by yourself, hopefully. Okay? All right, so now, okay, let me show you how to prove this, guys. Now, the thing to do here is to prove this, I want to find the MGF of z squared, right? Which is the expected value of E t z squared, right, which is the integral of e t z squared times, remember we are assuming that z is a standard normal variable. All of you guys know the PDF of the standard normal, right? What's that? Yeah, this is the PDF of the standard normal distribution, right? I'm sure you guys remember this. And the integral is from minus infinity to plus infinity. Yeah. Now, any ideas on how to integrate this, guys? You are the experts in integration. You've done 2 years of integration. So any ideas on how you can do this? Now, first of all, this function here, what can you say about this function? This is a, do you know some, you know what, I'm sure you guys know what an even function is? Yes, no? An even function is a function that takes the same value on the positive real line as in the negative real line. Yeah? So in other words, if, let me write this down on a piece of paper, guys, on a separate piece of paper. If g of minus x is equal to g of plus x, then g is an even function. This is the definition of an even function, guys. Yeah? Yeah? And if g is an even function, if g is an even function, then the integral of g from minus to plus infinity is equal to 2 times the integral from 0 to infinity of g. This is another property that you may like to know, guys. That if you haven't done this in your first year calculus course, you may want to know these two properties, right, or definitions, right? So this being an even function, we can say that this is 2 Yes? Are you with me? I just used this property here that if you have an even function, then the integral of that from minus to plus infinity is 2 times the integral from 0 to infinity. Yeah? Now, how do we integrate this, guys? To integrate this, you need substitution. So I'm going to do set this, right? So that will become yeah, and dz by dy will become, you should differentiate this, guys. You get what? You get this is what you will get if you differentiate this, right? Now put this in a box, guys, right? And sub this into this. You get This is what you will get, right? So this is now let me recall your memory, guys. I mean, I'm an old man, so you should have a better memory than I do. Now, can you guys tell me what this integral is equal to? This integral here I have written down. It's equal to what? Gamma of half, yeah, exactly, yeah. Now, what is gamma of half? I think I told you this before. It's root pi, exactly. So this guy is equal to yeah, the root pi and the root pi cancels. So the answer that you get is yeah. This is the correct answer. Just a minute. Well, did I make a mistake over here, guys? Come on. Is this correct here, guys? Just a minute. Shh. This one right? Is this correct, guys? I think there's a mistake here, guys. Just shh. You should differentiate this with respect to y. You get.
It should be 2 minus 14. It should be 2 minus 14 in the square root.
Yeah, 2 minus 14 the square root. Thank you, thank you. Sorry for being stupid one more time. I'm sorry for this, guys. This should be 2 minus 40, guys. This should be 2 minus 40. And this should be 2 minus 40. And this should be 2 minus 40. So hopefully this is right now. So it will be 1 minus 2t square root, which is the correct answer, because this is the MGF of chi-squared variable with 1 degree of freedom. Because remember, in the previous proof, I showed you the MGF of a chi-squared variable is 1 minus 2t to the power minus a by 2. So this must be the MGF of a chi-squared with with a equal to 1. All right. Therefore, we have proved the proof is complete. That is, we have proved that the square of z, where z is a standard normal variable, has a chi-square distribution with 1 degree of freedom, right? So it's not a difficult proof, except I messed it up, right? Now, okay, let me prove one more, because we are running out of time, guys. Let me prove just one more property. Right, this is a property of the T distribution, guys. Now, do you guys remember that if you have a random sample from a normal distribution, what distribution x bar has? Do you guys remember this from ages ago? It was, I mean, we did this like long time ago, guys. It's on page 6. If you look at page 6, guys, you will see it's by on page. If you look at page 6 of the lecture notes, you will see that the sample mean has a normal distribution with these parameters. Yeah? You see that or no? Right. Now, this minus this is equal to, talk to me, guys. What's this minus this equal to? Normal with 0 and sigma squared by n. Okay. Now I'm going to do the following. I'm going to pull out a sigma. You see what I've done? I have pulled out a constant outside, so the variance becomes 1. Yeah. Now this guy and this guy cancel out, so you have this. Yeah. Now, you should look at page 16 of the lecture notes. You will see that by definition, this is by definition of S. Now, this is equal to by equation 72 on page 16. If you look at page 16, equation 72, then you will see that this guy here has a chi-square distribution with n minus 1 degree of freedom. Now, this is equal to T n minus 1 by property A. Right? The final step comes because of property A, which is the property that I ask you not to prove, right? Remember property A, guys. Property A of student T, which is basically equation 77. Do you guys follow this proof or you're lost? Yes? Yeah. Are you okay, guys, with this? Yeah? Your answer? So this is the proof of property B of student T. Now, there are many other properties I haven't proved. Just please, when you have time, guys, try to prove the other properties I haven't proved. And if you have difficulties, guys, come and see me or send me an email. You don't need to make an appointment to see me, guys. I'm in my office most days except Mondays from 11 to 5 p.m. Okay? So just drop in and see me whenever you have a problem. Okay, guys? All right, guys.